Hey everyone, we are taking a look at a model of different blood vessels with their layers. So it's almost like a zoomed in microscopic look. This would be a longitudinal cut because you can see the length of each blood vessel. This would be a cross section since we can see the roundness of the cut. Let's take a look at longitudinal first. Well, first, how do we know what these blood vessels are? One of them is an artery, two of them are veins. How do I know what's what? There are several ways we can tell. The simplest thing is look for these valves. Only medium-sized veins have valves. Not large-sized veins, not venules. Only medium-sized veins have valves. So these are both medium-sized veins. And they tend to run anti-parallel to arteries. This is an artery. We know this because, one, no valves. Two, fairly muscular, really large region of smooth muscle. Veins do have muscle, just not as much. More proportionately more muscle. And because of that, the lumen of arteries tend to be smaller. The lumens of veins tend to be bigger. Okay, so let's take a look at the artery first. What are the layers of the artery? The first layer here in yellow, which you can see in this cut, and then also lining along here because we have this in 3 dimensions, that is endothelium. That's simple squamous epithelium called the endothelium. Really fun and confusing. Simple squamous epithelium making up the endothelium. The layer below it is the basal lamina, and together, this very thin layer of a single layer of cells plus connective tissue, that makes up the tunica intima. This is called, this region from here to here, a very small region, it's called the tunica intima. It's basically just the inner protective lining where blood will be flowing through. Oh, we would know that blood is flowing in this direction, so down, compared to the veins, because you can see that these valves, they would open up in that direction but not the other direction. You don't want the valves to open up that way. So because the vein blood flow is going this way, arteries always go the opposite way. One advantage of that is that it helps retain heat for thermoregulation. All right, but anyways, endothelium is the first layer, makes up the tunica intima. So from here to here, tunica intima. The next layer with all the muscle, that's tunica media. Tunica media. Bordering between intima and media is an internal elastic membrane. You can kind of see that represented here. Internal elastic membrane. Tunica media, here's smooth muscle that's cut. Here you can see smooth muscle. You can see it at that angle. See the smooth muscle wrapping around. And then on the outside, bordering between tunica media and tunica externa, this is the external elastic membrane. Arteries have an internal elastic membrane and an external elastic membrane surrounding tunica media. Tunica media is predominantly muscle and elastic tissue. And then you've got an internal elastic membrane and an external elastic membrane. The very outside, that's tunica adventitia. Tunica externa or tunica adventitia, it's the same thing. Adventitia or externa. It's primarily dense, irregular connective tissue. So once again, tunica intima, which has endothelium, tunica media, which has smooth muscle, tunica externa or adventitia, which has dense irregular. Bordering between intima and media is the internal elastic membrane. Between media and externa is the external elastic membrane. You can see that. So here's our artery. You can see that here. In yellow is endothelium. This white squiggly, which will be useful for looking when we see it in histology, that's the internal elastic membrane. Here's our smooth muscle. for tunica media. External elastic membrane is the border, and then tunica adventitia or tunica externa, the dense irregular connective tissue on the outside. That's for an artery, for a medium-sized artery. For a vein, going back to the longitudinal section, we've got our valves. Still has tunica, it has the same layers. Tunica intima with endothelium, tunica media with smooth muscle, tunica externa with dense irregular. The difference is there is no internal or external elastic membrane like there is for arteries. No internal or external elastic membranes in veins. So there are fewer layers. Looking at our cross section, endothelium, tunica media, tunica intima, tunica media, tunica externa. You can also see in this demonstration, in this model, that the artery looks nice and round while the vein looks collapsed. Arteries are much more reinforced. There's more muscle after all, so it keeps its shape pretty well. Veins tend to collapse because unless there's a lot of blood rushing through it, there's nothing to reinforce it. So veins tend to be more collapsed. If you physically feel a vein, you can press it. It collapses much more easily than an artery. Have you ever tried compressing like the base of a green onion versus the top stem part of a green onion? The top kind of just collapses. Veins are a lot like that, but the base is very sturdy because there's a lot of material there. That's like an artery. Just thought of that. Okay, I'm kind of hungry, I guess. Yeah, those are the layers of medium-sized arteries, medium-sized veins, and medium-sized arteries are otherwise known as muscular arteries. If this were large veins or large elastic arteries, what we would see is that in the tunica externa, in the adventitia, we would see capillaries. You would see capillaries, and that's the vasa vasorum. They get their own capillaries. All right, that's it for this. Let me know if you have any questions. Here are some smaller arteries and veins. Smaller artery, just coming from the middle, smaller vein. All right, if you have any questions, please let me know. Thanks for watching. See y'all later.